Hi, my name is Dominic Nally, and I'm going to be presenting on the branches of artificial intelligence. Now, artificial intelligence is a very scary and complex topic to many people, but I'm going to be simplifying that as much as possible. I'm going to be basically telling you the very basics of it. So I'm not going into much detail on the specifics of it, but I'm going to be explaining in a very broad sense, just to give you a little understanding on how it is. Uh, I work as an intern at a data lab for IBM with machine learning currently as an intern. So that's my qualifications for why I can talk about this. Uh, First of all, what is artificial intelligence? Now, as John McCarthy puts it, the science and engineering of making intelligent machines, especially intelligent computer programs. It is related to the similar tasks of using computers to understand human intelligence. And basically what he means is we're going to make machines that can think like humans, but can do it faster because computers are able to think faster than humans. So a lot of what artificial intelligence does is takes tasks that humans can do and has computers able to do it. It's a lot of automation. Some of it isn't automation. Some of it, you can see some like chatbots and stuff like that are interactive, but a lot of it is converting things that humans can do and having computers do it because they are much faster at doing it or more accurately at doing it, or it's safer to do. The three branches I'm going to be talking about are one, expert systems, two, machine learning, and three, neural networks or deep learning. And some of you, if you are aware of the topic, may say that neural networks or deep learning it's the same thing as machine learning. I disagree. I think it's a little different, even though it does stem from it. And that's why I put it below. I'll talk a little bit about what's the difference are later, but we're going to first start with expert systems. Now, expert systems are knowledge-based systems. And what that means is that they are provided a database that they can make decisions based off of. So it's a huge set of data, and it's just there for them to, pull from, to add to, and it's a lot of their decision-making process is based on that. Another thing that makes them special is that they are given a inference engine made by an expert, hence the name expert systems. So an expert will say, okay, you need to do this and this and that. And it's a set of rules that is given to make decisions. That's the whole point of an expert system. They're really decision-making algorithms, or not algorithms, but engines, and they make decisions. They're also provided with a knowledge set as well that experts would have. So experts would just give them a certain knowledge that they have. And based on all of that information, they're able to make very accurate and quick decisions on very complex topics. So for example, psychiatrists deal with these a lot. Back in 1955, one of the first psychiatry clinics used expert systems to help them make decisions for patients on all three aspects, from treatment to all the way from assessment to treatment. So up here you can see the clinic. Here's the data set into the hospital database. So this is the big database that the system will pull from. It has an inference engine and a knowledge base, and it has a user interface to work with. So a clinician would go up to it and be like, I have a patient with X, Y, and Z. X, Y, and Z would happen. It would look for anything similar to that. It would pull all the data that it could based on that. It would make a decision based on that data, and then it would output that a decision. And if that decision is right, it will say, okay, we had a patient with X, Y, and Z, and I made a correct decision saying it was this, and it would build. So it learns as it's being used. So it is self-learning in that way. So the more you use it, the more accurate it becomes. So that is the third special thing about it. Moving on, we're going to be talking about machine learning. Now, machine learning is very different in a lot of aspects. It's a lot more simple in how it learns, but it can't self-learn, like I said in the last one. It has three aspects to it, or three steps to its learning process. It has a decision process or an algorithm. So someone writes an algorithm to make a decision. It has an error function. So after it makes a decision, it has a function that determines whether it was right or wrong. And then it has an optimization model, which basically determines how it can make it better. So those three basically are the three steps on how it works. So it's it's given a set of data that is trained by the whoever makes the data, and basically has to learn before it's used. So it is given a set of data, and it learns that set of data, and any errors it makes, it will adjust until it can learn that set of data, and it keeps going until it's determined perfect. And then it can be used. So you'll see in this model here, it has a training and then a predicting model. So right here, it's giving input images of tumors. Some of them are tumors, some of them are not. And they are fed through the algorithm, and then they are predicted on. And based on how well it predicts whether or not it's a tumor or not, it will adjust until it can accurately predict pretty much all of the pictures. And once the engineer of the algorithm thinks the algorithm is perfect enough, they could start doing the actual predicting. So then they're giving just regular images of anyone, and then they can determine from that. So the process of learning is a lot different, but it's very effective on a lot of things. Another example, it would be your Siri and how it can use voice recognition. So there's that aspect. Voice recognition was used by machine learning, and more specifically, it was used by neural networks in deep learning. Now, the one big difference is the algorithm itself from neural networks. Like I said, it's very similar. It's the same process. So it has everything similar to a machine learning, but the algorithm is slightly different. It has these nodes, and this is supposed to model like a human brain in a sense. Each of these nodes are called a neuron, and they're given a weight. And based on that weight, they have a threshold as well. So an input is given and is giving a number. And now based on that number, it's given a threshold. So say it meets this threshold here. Now is that neuron has a weight. It's multiplied by that weight. And now it has a new number. And now it has to meet one of these thresholds. And it keeps going, right? And what you're going to end up having is you're going to have a bouncing around until you have a decision at the end. And based on that decision, if it's a correct decision, the weights are fine. If it's an incorrect decision, the weights will be adjusted based on the correct decision. So it's a lot easier to feeding information. It's a lot more accurate, and it can be a lot more extensive. So this is a very simple model, but these can go on. You can have hundreds of nodes, and they will go on forever. And each node has to connect to this one. So what you end up having is tons and tons and tons of lines. And so that's the more accurate part of it. So that has been my presentation on artificial intelligence and the branches of it. I hope I kept it simple for you. I thank you guys for watching, and yeah.